Hi there, I'm Gordon Ramsay, restaurant owner, chef, TV personality. I've been told that the engineers here at Northeastern University can't cook. Well, let's find out. Let's meet our three contestants.
Sean, wake up!
Oh, I'm Convection.
I'm Brendan. I'm Conduction.
I'm radiation.
So Chan, what are you cooking for me? Better not be just a potato.
I'm gonna cook you a potato. This equation describes convective heat transfer. Q is the heat flux, H is the convective heat transfer coefficient, Ts is the temperature of the surface, and T infinity is the temperature of the surrounding fluid. For our case, in a hot oven, H varies from 14.2 to 17.
Fascinating. Okay, Brendan, I've seen one potato today. What are you cooking for me?
I'm making a sweet potato. As you can see, the effects of conduction are at play here because heat is being transferred from the solid pan to the solid sweet potato. This can be displayed as Fourier's law, which is this equation right here. Here, the heat flux is proportional to negative K dt over dx, where K can be expressed as 0.49 watts per meters Kelvin.
Fascinating. Emma, tell me what you're cooking. I've seen 2 potatoes. Please tell me you're cooking something else.
I'm cooking a yam
How are you cooking it?
through thermal radiation. Thermal radiation is energy emitted by a surface at a non-zero temperature by this equation, where E is the emissivity of the surface and sigma is the Stefan Boltzmann constant.
You idiot! That's not how you cook a potato! What are you?
An idiot sandwich!
I want to try your potato.
Yes, chef.
Alright, Brendan, let me try your potato.
Yes, chef.
Emma, let me try your potato.
It's raw!
As you can clearly see, these dancers have no idea how to cook a potato, and their fundamentals of transport processes is lacking. Professional chefs wrap the potatoes in foil to keep moisture content inside their potato. When you don't wrap your potato, it is allowed to breathe. By this, the water goes through a phase change. This phase change requires a lot of energy. Therefore, the potato will take much longer to absorb that energy. It's essentially like your potato is sweating, not very appealing. Next, water has a very high CP, which is the heat capacity. This allows the potato to absorb a much higher overall content than if a potato was allowed to breathe. Lastly, nobody likes a dry potato. Next was Brendan, who, as a dunderhead, decided to cook a whole potato in a skillet. While this is a very common method, his actual execution of this was poor, piss poor. Normally, professional chefs cut the potatoes into either fries or slices. This maximizes the ratio between the surface area and the volume that you're cooking in. That causes the heat transfer to overall increase through each individual piece. Next, because he's a complete dunce, he did not use olive oil to cook his potato. Oil has a very good heat conductivity, and when it's in contact between the pan and the potato, it causes the heat to transfer at a much greater rate than if you did not use oil. Finally, anybody who lacks oil in their pan is going to make a dry, tasteless end product. Finally, Emma, being a complete idiot sandwich, thinks that a microwave heats up and gives off thermal radiation. This is not correct. A microwave oven does not use that. It uses actual waves that pass through whatever food you're cooking. In this case, a terrible, terrible potato. However, Emma's explanation of black body radiation is correct, but she does fail to cook a passable potato. So, are the assumptions that Northeastern engineers can't cook correct? Yes, emphatically yes. Do not eat any food cooked by an engineer from Northeastern University. I'm Gordon Ramsay.